In this video, we'll go over how to make aesthetically pleasing plots for our logistic model. So remember, if we just rerun that model we just put together, eventually a plot will pop up like this. Now, a couple things to notice. Of course, we can sort of drag around and things like that, like we did last time. But a couple things, there are no axes labels, either on the independent or dependent axes. The line of our solution is rather thin. There's just ways we can make this a little easier to interpret. Also, the font size is very, very small. So there's some of the questions that we're going to cover. Axes labels, fonts, line thicknesses, things like that. So let's go ahead and just jump into this. So if we go back to our logistic model, I guess the first thing we could do is just get rid of those length commands since we've already debugged that. But we can add the first thing, axes labels. And the nice thing about MATLAB is the axes labels are actually pretty easy for us just to define. So the first thing we can use is this command that's just X label, open, close parentheses. Now we're allowed to put a string inside of here, and that'll just pop us or pop the independent axes or independent variable axes with whatever label we want. So for example, in this case, we want this to be like iteration number to go on that horizontal axis. We do something similar for the vertical axes. Now this is, we could say, since this is a logistic model, we could say this is population, we could say this is logistic solution, whatever we want. In this case, let's just go with population. And put some comments. This labels the y-axis or the vertical axis. And the x-axis, x label, labels horizontal axes. So let's go ahead and just rerun this. All right, we have two axes labels now. We see that iteration number. We also see population pop up. Again, the font size is very small. Could be hard to read if this was on a poster or even turning in for a homework assignment. Also, the solution itself is very thin. It's also not displayed in the best way where it almost doesn't, it looks very close to that 250, but you almost don't know the solution's there. So let's make this a little more readable. The first thing we could do, let's thicken up that line. And the way in which we can do that is if we go back to plot, we're able to put basically plotting attributes after we put the independent variable and dependent variable. And all these things are going to be separated by commas. The first two things it knows are the dependent or independent and dependent variables. We can do something like put this dash inside of the apostrophes. And now we know we're going to connect point to point. If we do something like a dot slash, it'll put a little dot everywhere we're stepping iteratively. So let's just take a look at that. Oops, invalid expression, use parentheses. There's something funky going on. Oh, we have that extra comma there. Rerunning this. You can see these small little dots that are actually our solution at every single iteration, and those lines are just connecting the dots. Those dots are small, lines are still pretty thin. So let's increase the size of the dots and increase that line thickness. So the first thing we can do, let's increase the size of those dots. And the way in which we do that is a command called MarkerSize, which again, we're just putting a comma for apostrophes inside those apostrophes, MarkerSize for that specific attribute. And then in here, we can tell it a specific size, something like, let's just see what 20 looks like. And going back to running this, those dots are now a lot thicker or a lot bigger. Perfect. All right, well, let's thicken up those lines. And line, or the command for line thickness, is LineWidth, if I spell this correctly. And again, that's just separated by a comma, the apostrophes for whatever string, in this case, line width for the line thickness. And we can put a number after this, say 4. In these 20s, these 4s are things we could change if we want as well. So if we rerun the model, you can see that that really thickens up kind of the lines in between those dots. Maybe let's increase that thickness a bit, increase that thickness of, or the size of the dots, 30 for marker size, 5 for line width, and let's just go forward and see what that looks like. Okay, but either way, you can see that we are starting off with a thicker line. We're putting a point every single time we have a different iteration. So you can see what the specific iteration values are. But the last thing we could really do is, well, these axes labels, they're still really small font size. The axes values themselves are very small in terms of font. Let's increase that font. Also, let's reshape this plot so we can actually see the solution in a much cleaner way. So to increase the font size, we use a command called GCA, or sorry, set, and then GCA, comma, and then our string that we want to change, font size. And then from here, let's just say the font size is, I don't know, 22. Let's try to run this. Now the font size is much larger. It's a lot easier to read. You can tell this is a little more aesthetically pleasing of a plot. I'll just add a little note here. Changes font size on axes labels. All right. The last thing we could try to do is, again, if we just rerun this, we might want to change just the values that the axis takes on. So instead of going from 0 to 250, maybe we want to go from 0 to 350 or 300 on the vertical axis, and go from 0 to 100. Maybe we want to go from like -5 to 105. Something like this, just so we can see all of our data is contained inside of that window. So again, let's change the horizontal axes instead of 0 to 100 to -5 to 105. And then let's also change the vertical axes instead of 0 to 250. Let's change it from, I don't know, 0 to 300. And the way in which we do this is a command that's just called axis. We can do open, close parentheses. And inside those parentheses, we'll do open, close square brackets. So there's a lot of stuff going on. And basically inside of these square brackets, so I'll make a couple notes here. So square brackets. The way in which this works is we do the first number is the x low value, or the smallest value or the most left value for the horizontal axes. The next is the x high, or the rightmost value on the horizontal axes, followed by the lowest value on the vertical axes, y low, followed by the highest value on the vertical axes. Now we could define variables for each of those things, but what we actually want to do is, well, if we want to go from, say, -5 to 105 on the horizontal axes, we could just say this is, -5, this is 105, and we can do something similar for the vertical axes as well. So we're going to do this in a moment. So let's just go from, I guess, y low, 0, y high. I think I said 300 before. And you can, of course, change these to make the plot look better in your opinion. So -5, 105, that covers X low to X high, or the leftmost value on the horizontal, rightmost value on the horizontal, 0 for Y low, and 300 for Y high, the lowest and the highest value on the vertical axes. So let's try to rerun this. Rerunning this now, you can see that certainly changed our solution. Or what this, not change the solution, but changed our depiction of that plot. So all the data for our solution is now clearly contained inside. We can see very easily that this is steadily going off at 250. Oops, click the help browser. And if we wanted to, maybe instead of going from 250, because there's a little bit of extra white space here, we could have went, or sorry, from to 300, we could have went to say something like 260 or something like that. But I hope this gives you a sense of how we can make sort of these lines thicker, these dots larger, and change the font size on these plots as well.